Good evening, Doctor. So today we are going to present about the group assignment for BEKG 2443 Engineering Mathematics 2. So the selection of Engineering Maths 2 topics is triple integral in cylindrical coordinates and divergence theorem in green theorems. For the engineering application topics, we choose electrical, that is vector analysis from electromagnetic theory. I'm going to introduce what is Green's theorem. In vector calculus, Green's theorem relates in a line integral around a simple closed curve C to a double integral over the plane region D, bounded by C. It is the two-dimensional special case for Stokes' theorem. So as let C be a positive-oriented, piecewise smooth, simple closed curve in the plane, and let it be the region bounded by C. If L and M are functions for the xf defined for an open region containing D and having continuous partial derivative, then there were the path for integration along C and D clockwise. In physics, Green's theorem finds many applications. One is solving two-dimensional flow integrals, stating that the sum of fluid outflowing from a volume is equal to the total outflow sum about an enclosing area. In plane geometry and in particular area surviving, Green's theorem can be used to determine the area and centroid of plane figures slow by integrating over the perimeters. So as can see, the formula for the Green's theorem is shown as L dx plus m dy equal to double integral sigma m over sigma x minus sigma l per sigma y.
Hi, for my part I'm going to explain about question 1 and its solution. So let's begin. Applying Green's theorem for magnetic flux across a circle. Let R be a circle of a radius r, center at the origin, and let F equal to coordinate of x and negative y. Calculate the magnetic flux across C. So the figure below shows a curve C is a circle of the radius which is centered at the origin. The magnetic flux across C is an integration of F theta dr. Let R be the disk enclosed by C. Consider the vector field of F is equal to coordinate of x and negative y on the unit disk R, which a coordinate of xy is equivalent to x power of 2 plus y power of 2 is equal to 4. Let P become x and let Q is become negative y. C is a boundary of R which are oriented counterclockwise. Evaluate the integration of f theta dr using a Green's theorem. According to the solution, we let P is equivalent to x and let Q is equivalent to negative y. So that we use the f is equal to coordinate of P and Q. For the radius part, we express R into x power of 2 and y power of 2 is equal to 4, which means the radius is equivalent to 2. So we express the limit of the radius from 0 to 2, and we express the angle theta, the limits equal between 0 and 2 pi. According to the Green's theorem formula, we use the formula of integration of the p dx plus q dy. So we use the value of the p and q differentiation. We place into the formula, so we get the integration of a 2dA. So after this method, we use the area of the region R, which pi r square. So we place the 2 into the formula of a pi r square and times with 2. So we get 8 pi. Therefore, the magnetic flux of the C across C is 8 pi.
Assalamualaikum, my name is Muhammad. Next, we will continue with question 2. Applying Green's theorems for flux across the triangle. Let S be the triangle with vertical 0, 0, 1, 0 and 0, 3 oriented clockwise. Calculates the flux of F xy equal P xy, Q xy equal x power 2 plus exponent power y x plus y across S. Okay. For this graph, we can get from the MATLAB. So we can know at the MATLAB we can get this graph or from my calculations. Okay, next, to calculate the flux without Green's theorem, we have to break the flux integral into 3 lines integrals. It is because one's integral for each side for the triangle. By using Green theorem, the flux line integral into a single double integral is more simple. Okay, from this question, this is my solution that we discussed. Okay, first, let D be the region enclosed by S. Let PS equal to S and let QY equal to 1. So that PX plus QY equal to X plus 1. This is formula for the Green theorem. After we convert from PX plus QY to the Green theorem, we can get a negative double integral to X plus 1 dA. Notice that top edge of the triangle is the lines y equal negative 3x plus 3. Therefore, in the literated double integral, the y value run from y equal 0 to y equal negative 3x plus 3. This is formula for Green theorem. Okay, we do the first integrate to negative 3x plus 3 and we get negative 6x2 plus 3x plus 3. Okay, after that we do the second integrates. After we do the second integrates, we get the integrates negative 2x power 3 plus 3x power 2 divided by 2 plus 3x. So we continue with, we replace the x with 1s and 0. Negative 2 multiply 1s power 3 plus 3 multiply 1 power 2 divided by 2 plus 3 multiply 1s subtract with 0, and the answer is negative 5 per 2.
The MATLAB output design for first solution, which is the circle. So here, as you can see, the circle t is equals to line space 0, 2 pi. The 2 pi will be the value of a full circle. As you can see here, a full circle. And next is x equals to 2.5 cos t plus 0. And here 2.5 is the value of r, which is the radius for the circle. As you can see here, 0 to 2.5, and 0 is the value of origin coordinate for x. So here is the origin, is 0. Same goes to y, equals to 2.5 sin t plus 0. Same thing, 2.5 as the radius and 0 as the origin. So here you can see the full circle, same as the solution for number 1. And next is the number 2, which is the triangle. So here you can see x equals to 0, 1, 0, 0 and y equals to 0, 0, 3, 0. This is actually the value of coordinates x, y for this diagram. As you can see here, 0, 0 is here, 0, 0, 1, 0, 3, 0 and back to 0, 0, and it turns out to be a triangle. So that's all from me. Thank you.